Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to factor quadratic expressions where a, the leading coefficient, is not equal to 1. So the instructions for the example that we are going to be doing, we are to factor and check by expansion. Okay? So we're going to factor the given expression, and then we'll check for the accuracy of our result by expanding. For question number 1, let's say we have the quadratic expression 8x squared minus 10x plus 3. Okay, so here we have a quadratic trinomial. Anytime we're factoring, we always want to ask ourselves, is there a greatest common factor that can be extracted from all three terms? So if you take a look at that 8, the 10, and the 3, you can clearly see that there are no common factors that can be extracted. If that's not obvious, you can go ahead and decompose the numbers. So if you decompose 8 into product of primes, you have 2 times 2 times 2, and then times x times x. If you decompose 10, you have 2 times 5 times x, and then 3 is prime, so it stays as 3. Now if you take a look at the decomposition of the three terms, you'll find out that there is no common factor that can be pulled out. Alright, so what we'll do is we are going to combine the numbers. Again, combine the factors to generate the original problem, 8x squared minus 10x plus 3. Okay, in this setup, let's go ahead and write down what a, b, and c are. So a is the coefficient of x squared, which is 8. B is the coefficient of x, which is negative 10, and c is the constant, which is 3. All right, so you want to remember the form. You want to recall the form ax squared plus bx plus c. The general form of a quadratic tells you what a, b, and c are. Okay? Now that we have that set up, we want to express this quadratic trinomial as a quadratic with 4 terms in such a way that we can pull out a common factor from the first two and the last two and have identical factors in the parentheses upon the factorization. So in order to do that, we need to pick two special numbers. Okay? The condition has to meet the setup of something called the x game. Okay, so let's go ahead and set up our nice little x. Now for the x game, we are going to have AC on the top and B on the bottom. AC is 8 times 3, which is 24, and B is negative 10. So the question is, what two numbers multiply to give you 24 and add to give you negative 10? If you're not sure of what the two numbers are, what you can do is set up a product table and write down the product of numbers, integers that result in 24. Okay? And then after generating all the product of pairs that yield 24, you ask yourself, which combination can give me 10 upon addition or subtraction? Okay? We'll focus on the numbers right now and then deal with the signs later. So we know 1 goes into 24 24 times. 2 goes into 24 12 times. 3 goes into 24 8 times. 4 goes into 24 6 times. 5 doesn't go into 24. We have a complete loop. Okay, so which of this combination of pairs can yield or will yield 10 upon adding or subtracting? The first one yields 25 or 23. The second one yields 10 or 14. Let's go ahead and try that one first, okay? So what if we put 2 and 12? Now we have to fix the signs to see if it works. The sum has to be 24, which is perfect. The the product has to be 24, but the sum has to be negative 10. In order for the sum to be negative 10, that means the bigger has to be negative. So we have a situation here where 2 minus 12 is negative 10, but 2 times negative 12 is not positive 24. So this doesn't work. Let's go ahead and change the sign of the bigger number to a positive, and then let's make the sign of the smaller number negative. It doesn't even work. It doesn't yield negative 10, nor does it yield positive 24. So what does that tell us? It tells us that 2 and 12 is a good distractor, but that's not the combination we are looking for. So we continue going down our list of pairs to see which will yield the desired sum and product. Okay, so 3 and 8 gives us 11 or 5, no good. 4 and 6 gives us 10 and 2. So let's try out 4 and 6. Okay, so let's put in 4 and 6. Now, in order for this to work, in order for the sum to be negative 10, both of them have to be negative. So we have negative 10, and the product is 24. So this is the pair we're looking for. 4 and 6 works perfectly. Okay. Now we're going to factor by grouping. So let's go back to this quadratic trinomial. We're going to take out the middle term, negative 10x, and replace it with these two numbers, negative 4x minus 6x plus 3. Okay. Now we're going to go ahead and divide it, split it down the center in front of the sign, and now we're going to factor by grouping. So we ask ourselves, what is the GCF of 8x squared and negative 4x? What's the biggest number that goes into, or biggest term that goes into 8x squared and negative 4x? The answer is 2x. Okay. Now, if you're not sure how to visually determine what the GCF is, what you can do is you can decompose your terms again, so it's easy to identify the greatest common factor. Okay, if we decompose 8, we will get 2 times 2 times 2 times x. If we decompose 4, we'll have 2 times 2 times x. Decompose 6, we have negative 2 times 3 times x. 3 is prime, so it cannot be decomposed. Now, if we take a look at the left side of our partition, well, I'm missing a 2 here, so it's supposed to be 3 2's. Is there anything that's common, any common factors to the left of the partition? There certainly are factors. We have 2 2's to the left and 2 2's to the right. We also have 1x and 1x here. So let's go ahead and pull out the greatest common factor. So the GCF here is going to be 4x. So if we pull that out, we have 4x. And we're left with, now if you take out the 4x's, what will happen is that it's as though you were dividing by that. They're gone because you factor them out. And you're left with 2x minus 1. Okay? Now if you take a look at the two terms to the right, what's common? What's common there is 3. Now something to keep in mind is that you always have to pull down the sign to the right of the partition. So if it's plus, you bring down the plus. In this case, it's minus. This means that we're factoring out a minus, which will switch the signs of these two terms. Okay? So we're factoring out a negative 3, so we're left with 2x. Okay, and then this plus becomes a minus. Since we factored out the 3, we're left with 1. Okay, remember when you factor out common factors, it's as though you're dividing by that number that you factored out. So if you divide 3 by 3, you have 1, and then this one is also 1. Okay, Now this is where you freeze and check your work. If you take a look at what we have here, if it's done correctly, the quantities in the parentheses must be identical. Is that the case here? Absolutely. To the left of the partition, we have 2x minus 1 in the parentheses. And then to the right, we have 2x minus 1 in the parentheses. So that looks great. So what we're going to do is pull these two common factors out. We have the quantity 2x minus 1. And then 4x and negative 3 will be grouped into their own parentheses. So we have 4x minus 3. Okay? So the answer, the factored form, the desired result is 2x minus 1 times 4x minus 3. Okay? Now the question is this answer correct? Let's go ahead and do a check here. We're going to check by expansion. Okay, so we have 2x minus 1 multiplied by 4x minus 3. So what we're going to do, we're going to distribute first, outer, inner, and then last. Okay, let's see if we get the original problem. If we do, that means our factorization is in fact correct. Alright, so what is 2x times 4x? That's 8x. 2x times negative 3, that's negative 6x. Actually, 2x times 4x is 8x squared. 2x times negative 3 is negative 6x. Negative 1 times 4 is negative 4x. And negative 1 times negative 3 is positive 3. If we combine the terms in the middle, we'll end up with 8x squared minus 10x plus 3. Now, is this the same expression we had at the start? 8x squared minus 10x plus 3. 8x squared minus 10x plus 3. That means that our factorization is in fact correct. Okay? So that is how you factor quadratic expressions where a is not equal to 1. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study of the factorization process, mainly quadratics, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial, or any concepts in Algebra 2 all the way to calculus in general, just place your questions in the comments section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other math tutorials such as this. More clips and resources, worksheets and formula sheets can be found on math.serve.com, so I encourage you to visit it. Thanks again for watching, and have a wonderful day. Goodbye.